and share it. So we'll talk about WCF today. We'll do an example together, but I hope that we'll have time to break for you guys to split up into your groups to start beginning your ideas for your group project. The group project itself, the requirements will make a lot more sense after we've talked about WCF. So we'll talk about that afterwards, and then we'll be able to put everything in its place and think about what needs to happen for that. That's it. I like talking about it. All right. I hope y'all had a good weekend. I didn't do as much work this weekend as I should have. That's all right. So WCF, do you ever do that game with yourself where you try to figure out what the acronym stands for, even if you don't know what the acronym stands for, kind of the acronym game? That's such a good game to have if you're a computer person, because you're always trying to figure out what the acronym stands for, right, in our field. So WCF stands for Windows Communication Foundation. So networking, pretty much what we're going to be doing here. Why would we need to network? Well, because we need applications that run over the network, over the internet, or our local network, whatever the case may be. So there's lots of ways that we can implement those kinds of applications with Visual Studio and C#. We saw last week ASP.NET. We looked at our quick overview, and hopefully you watched those videos to get a little deeper into things, to see that we can have web-based applications, kind of HTML, CSS-based applications that come from Windows, because Windows or Microsoft wants to compete with all those open source products that are available. WCF is the back end. So here with WCF, we can communicate with other applications and other interfaces via the network. So it's services that allow us to create APIs that are available over the network. So their blurb, WCF allows for consistent internet-based communications. And if you're running Casey's, you want to have consistent internet-based communications, right? You don't want to be dropping packets when you're looking at people's credit card numbers, or having communication failures when you're trying to charge people for the gas they bought, because you want to make sure that you get that income. So we want things to be consistent and reliable. There are many, many, many different standards and protocols available for communicating over the internet and across the network. So it's nice to have some standards, some standardized ways of communicating, so that we can have, like WCF offers, this unified platform where everything works the same and we know how to connect to services that are available to us. So in effect, WCF is how to create an API, an endpoint for others to connect to our services. So here's an example. If I go to my bank and use an ATM, like I'm right there at the bank, there doesn't have to be a lot of network communications, right? It could be cabled directly to the servers inside the bank, and it could be all connected and everything work seamlessly, and me not have to worry, and them not have to worry about any communications platforms. But what if I'm traveling? Now, if I'm traveling somewhere and I still want to be able to use an ATM, I have to have some sort of way to communicate with that endpoint, right? That home bank, because La Bank here is not going to give me money on my debit card just because my debit card fit in the slot, right? They're going to communicate with my bank, make sure funds are available before they give me any money. So that sort of communication has to occur somehow, and it has to occur over the network. Now, when we're using ATMs, they have their own set of protocols, so they're a little more specific than what we'll be getting into, but I want you to think about that concept, that it's distributed. It's distributed processing that's distributed worldwide, and we want things to work the same no matter where our product is being used. So we can create a web service or an API to handle both local and far away. Distributed. So here we have our server. And on our server, we have our trusted databases here, and we're running our WCF services. Then out here in the field, we have client number 1 that can connect to our service and do whatever kind of service we offer. And we have client number 2 that can connect. So in this picture, they're working with different services, but they could be working with the same service as each other. Just the same API is how we connect. So it lets us really expose our offerings out to the world. So how does WCF do this? Well, WCF is basically a class or a class library, and it allows us to call it from other machines, from other classes. The WCF class opens up common data formats and protocols. So it understands how to read XML files, JSON files. It communicates via the HTTP protocol. We use the HTTP protocol every day when we're communicating over the internet. So it uses a common protocol that's not usually blocked, if you think about it. If you're common with networking type concepts, you know that if I use a file transfer protocol like FTP or something like that, that protocol is commonly blocked on networks. So by using HTTP, that's a protocol that's usually open, that doesn't cause any sort of security problems. And of course, we're going to wrap up our package so that it's not available to network hackers. Now we have these WCF classes, and we'll use those classes, and we'll have that information saved on our server, and then all of our clients can now access that machine or server using the API that we've exposed. So WCF by default is distributed because it lets us run our processes over the internet or whatever network we want. Now, whenever we're working with network access, we have to be concerned about protocols. And probably you've heard the term before, but just to be clear, remember a protocol is an agreed upon set of rules for communicating. So if I'm using the English language protocol, we have a certain agreed upon set of rules. If I'm writing things, I'm supposed to use an exclamation point to show excitement. I'm supposed to use a question mark to show questioning. Those are established protocols and rules that we have for the English language. So if I'm communicating with somebody, they know how to interpret what I'm saying. Now, if I am communicating with somebody who uses a different protocol by default, maybe their protocol is German, and we're communicating, we could have some communication failures. We need to be using an agreed upon protocol that both of us can understand to have effective communication. So there are protocols that are available for this message processing that we're going to do across the internet. One is called SOAP. SOAP stands for Simple Object Access Protocol. It's XML based, so we have an XML file that says, you should use HTTP port 80 to communicate. You should use this standard format. So SOAP is one protocol that we can use, that we can agree on. REST, Representational State Transfer Architecture, that's fancy, isn't it? This is another protocol that we could use, that we could agree upon. If we were using REST, we wouldn't be wrapping our data up here with HTTP. We got to wrap our data. We got to make sure it's safe. We're running that right across the network. It's wide open. Anybody could be doing a network packet sniffer or something and see our data, so we have to wrap it. Using REST, we're not using that standard HTTP protocol, so we don't have to worry about those security kinds of issues. It's more secure by default. But it uses get and post type commands. So we might have to have a little bit more code on our end to say, did you get that? Did you get that? Did you get that? Did you get that? And we're going to keep asking until they reply with a post. I did. I received that. You can post yourself. All right. So that requires a little bit more back and forth communication to get and post. So when we're communicating over the network, we have to decide, is this going to be a SOAP protocol service, or is it going to be a REST protocol service? That's a decision we have to make. So look at those. No matter which way we go, though, there are some components that we'll have to be concerned about as we set this up. First of all, the URL. Where is our service going to live? Is it going to be on some web server named www.otc.edu? Am I going to put it on some Amazon web server where I'm going to have one of those really long URLs like we do for our database server? Am I putting it on the server right next door where it's going to be joebob.com? I can do that. So wherever I want to put this service, I can, but I need to know what's the URL. How do you get to it? That's the endpoint. How does somebody connect to my service? Has to have an open spot for them to connect. Another thing that we have to decide when we create a WCF component is how is it going to be bound? Is it going to use SOAP or REST type communication to bind with the client? And then contracts. Let's see what those are. Oops, this weird thing is in the way. I don't know if I can, oh, I can close it. Whoops, that wasn't what I meant. That was some handsy PowerPoint helper, huh? Get out of my way. There it goes. All right, so a contract includes all of those things. In our contract or XML file, we're going to say what interface we're using, what services we're going to expose on the web. Are they going to be SOAP services or REST services? And then we can choose which methods basically from our code we want to expose on the internet. Is my get product code method going to be available for people to use so that they can find our product codes information? Or is it just going to be like get sales around? What methods am I going to open up? So I have my host, my web server where my service is living. Could be anywhere. But here's my service then running on that web server on that host. It's exposed these endpoints. Endpoint number one is get product code. You want to find out what the current price is for that product? Get that product code and I'll give you back the current price. And have you guys worked at any place? Do you know how common that is now? I gather from people working at places like Walmart and other places that it's very common to have product pricing established at the corporate office. And so that cash register, every time something is scanned, can actually communicate with Bentonville to determine what the price is for that item. So Bentonville can react very quickly and say, oh, Price Cutter just announced a sale, so we're going to lower the price of that item in all of our Springfield locations. And they can handle that without people in Springfield having to do anything. So a lot of these endpoint services are established for things like that right now, people that are communicating over the network. So get our product information, get a tax amount, get a credit limit. All of those different kinds of methods might be exposed as endpoints. They're open spots. Then my clients can come along via the internet and connect to those endpoints and basically run our methods and get that information back that's supplied by our method. So if client one connects to the get product code endpoint and passes in a product code, they will have the product information returned to them. And when they do that, they're consuming that service. So we have our consumer out there, that little client sitting there running some sort of Visual Studio application that creates the WCF client process. Our WCF client connects to one of our endpoints, which does some connection to the server, gives them back the information that they've requested. Whenever a client begins requesting service, the server is going to respond to the first communication with information about how to connect, that binding information. The client then is going to review that information and respond saying, yes, I can communicate that way. Here's my security credentials. And then the server is like, oh, okay, you look good. I'll go ahead and communicate with you. Once that handshake has been completed, they can transmit data back and forth. When we're transmitting data back and forth, we have what's considered to be a communication stack running on each machine. So here's my client machine. I'm using some sort of XML connection that's all serialized and safe and secure. So I'm going to let Windows and Visual Studio and all these different services process my message. It's going to be reliable. It's going to be broken up into a transaction. Security is going to be established as necessary. And then that encoded message is going to be transferred across the network, whatever kind of communication channel we have, many different communication channels depending on where we have to go. And then the server is going to receive that encoded message. And it's going to unwrap all that information. So it's going to take off the security layer and take off the transaction layer and the reliability components that were added until it finally gets to that original XML file that that client was sending. But we have to do with all that wrapping to make all that data safe as it's transmitted across the network. So a lot of overhead to make sure that our data is not stealable, grabbable. Now, with all this overhead, why do we want to do it? Well, obviously, we have all these benefits. We can get to our data across the network. If we're Walmart, we can check in Bentonville and say, what should the thermostat setting be at the store in Springfield? And we don't really care about what the temperature is, right? We can access the data. We can find out a customer's credit limit. We can find out how much they have in their account that's going to handle this amount. So we can access data over the network. We can perform complex computations. So as I mentioned, Walmart might want to raise the price or lower the price all across Springfield, but they might do things that are much, much more involved than that. They might do some calculations based on, you know, the temperature and the average sales from the last 5 years and this and that and the other. What should they make the price? So we can have very complicated things going on the server side that the client doesn't have to worry about. We can ensure data integrity. If you connect to my server and get information from me about my customers, you know that information is up to date and accurate. If you connect to Joe Bob, who's a third-party website scraper who grabs information off of other websites overnight, information may not be as reliable. So we can use these features to ensure the integrity of our data, make sure that what people are getting is actually what we want them to get. Another really important benefit is that we can have one service that all sorts of different clients can access. So again, if I have a product code lookup service, all of my sites could access that. If I'm Menards, they could all find out what that product is and how much it costs. But I could also use that same service for my web programmers so that in the web app that allows people to shop on the internet, when there's product information to be gotten, it can use that same web service. So we can have this one service that's used by many, many different things, making us more efficient. Okay, so how are we going to create it? We're going to create a web service first as a template to try the template one and see what all is involved, and then we'll create one ourselves. Now, when we create our web service, we're going to have a method that we expect a parameter input to. So let's say hello world was our method. In this case, it's get data. The method is going to be created in our service. We have to run that somewhere. By default, we would be running this on a web server, but Visual Studio gives us the ability to use a test system to emulate the running of our service. So we can do that on our local machine, and then we'll create another project that acts as our client to connect to that service. So we'll have to have two different pieces or two different projects to actually test it out. Thinking about how in the end, we would want this to be on a web server and this to be on a client machine. We'll think about, should we make them two completely different solutions or two different projects? So many different ways we could set it up. Now, when we create our web service, you'll see that you'll have to use those badges. The first time you've seen the badges for C# was the serializable badge with the square brackets above your class name. You're going to see some more badges for some of these interface options that we'll use for WCF. The badges are going to define the different parts of the interface, plus they're going to be like operational contracts. Wherever there's a badge, it's going to define, this is like an endpoint. This is a method that should be available over the network. So we're going to expose badges that are operations and some that are data. You'll see it's pretty simple. And then we'll run it. Let's try it. We don't need to look at all this stuff. It walks you through it, though. This PowerPoint is online, so if you need to see it, it's out there, but let's just try it. So I'm going to open Visual Studio. And find our textbook here. Now this is in section or chapter 23 of our textbook, and so we're going to try, I'm going to be looking at the section where they step through creating the WCF template service. So that's where I'll be getting all that information if you want to try it on your own later. So let's create a new project. And so the last time we created a project, it was an ASP.NET, and we want WCF, and it's sort of web-based, but they pulled it out and it has its own category. So we'll look at WCF Services. Now we could create a WCF service library, which would be a class library, a WCF service application, and notice that it's hosted in Internet Information Server or an Amazon service. And then a syndication service. I'm not super familiar with that. So let's see what kind they want us to create. We'll just try one. I think we want this service application. And let's name this Chapter 23 WCF Service. So because we use that application, it has created some template information for us. I'm going to look at Solution Explorer over here and see what we've got. First of all, as we look through our components that were created for us, notice our project icon is that web service icon that we saw with our ASP.NET project. It has this connected services cloud-based icon underneath it that doesn't really have any data yet. We'll be getting some information. put there. It has an app underscore data folder, kind of implying that's where I would want to put data files. And then it has these service files. Let's look at service1.svc.
Mine does not appear to have a connected services bit.
Go back and create it again and choose the, are you running 2017 or a different version?
2017, off of the OTC computer.
Do you guys have that WCF application option? Did it give you this stuff? Oh, choose WC. I think so. So yeah, throw it away, grab a new one. It's cheap. We can do it. So if you look at service1.svc, I'm going to expand it a little bit. It has a code behind file, that .cs file, and that's what we're really looking at here. So
just to be sure I'm getting it right this time, I need the WCF service application, not the library.
Right. So our service1.svc files code behind .cs file, if you notice, is not very full of things, but here's our class, and it inherits from the iService1 interface, which look is right above that in our code. We'll look at that in just a second. So that's something we control. But in our class for Service1, we have a method called getData. It expects a parameter that is an integer to be passed to it. All this method does when it's run is return a string that contains the output you entered and then whatever value was passed to it. So it's a quick back and forth, right? If we execute this method in a distributed manner, we should send it an integer and we'll get back this string message that says you entered and then our integer. Now, if we keep looking down, you'll see that we have a get data using data contract method also. And I'll let you look at that. It's just doing some work in case we want to. It's an example of how we could do some things if we wanted to combine multiple data types. And that's it. So some sample methods for us. Now let's look at iService1.cs, our interface. In our interface, we see those badges. And we say, we're issuing a service contract, and our operation contract, the operation that users can do with our service, with our API, is called get data. That's all they can do. So by saying we're opening an operation contract with get data, that's an operation that people can perform in a distributed manner with our service. They could also use this get data using data contract operation if they wanted to. So that's all our services opening up. Now, data-wise, we can return this composite type. And so it's an example for us of a more advanced return type. Return a Boolean or a string, depending on what's going on. All right, let's look at our web.config. Not too much in here so far, is there? It's just the fact that it uses those web services that give us this capability. But behind the scenes, there's some networking going on, but the C# code that we see is not that different than C# code that we would see that's running all on the same machine. Looking at our web.config, we can see some important points. First of all, people can use our service via HTTP as a protocol and HTTPS. So if they were running a secure encrypted HTTP protocol, we would allow them to still use our service. We have bindings for those, HTTP and HTTPS. And that's about it. So we shouldn't have to work with this too much unless we have some sort of network issue. So that's pretty much everything in our service. So this is our service that's going to run on the server. So we need to get this thing running somehow so that we can connect to it and see what it does for us. Now, right now, if I click start, I've got that same start button as I did using the ASP.NET application, like it's going to run in Chrome. I'm going to try it. Right now, if I run it, all I'm getting is a file listing of everything that's in my project folder. That's not very helpful. So what I need to do, and this is really important, is I need to be looking at my service1.svc file before I run. When I do that, I get this nice little WCF Test Client dialog box instead of my web interface listing of all of the files in my project folder. Is everybody getting it? Click on your .svc file in Solution Explorer and then click Start. Now, again, if I were running this on a web server, I wouldn't need this test client, right? Because I would just be able to start up my service on that web server. But since we're doing everything on the same machine, we have to emulate having that server. So this is emulating that server. But it also gives us some great information about our web service. Let's take a look at it because it can be really helpful. So our web service here is named iService1. That's true. That's what our class was named. It opens up the interfaces that are listed below, really the methods. If I click on Get Data, show me stuff. Oh, I had to double click it, sorry. If I double click it, it actually opens up a test window for me to test that service. Well, we remember what that service was supposed to do. We're supposed to send it a value and then it replies with a message. So let's test it. I want to send it a value. And I got this reply, you entered 0. Well, I want to put something in. Where is it? There it is. It's like somewhere I can test it. So I'm going to invoke. And now I've got my you entered 2. So I am able to actually test my service via this interface. Pretty handy, pretty handy. So everybody's working okay? You see how it does it? So if I had something set up where I was replying with all of this product code information, my method would have a lot more stuff in it, right? Or it might call some other methods. I might call my data adapter to go get that product code information and return it to me. And then I might format it some way to return it to the requester and get it all out to them. But I could work on this service as long as I want to get it just the way I want it to be before I use it over the internet and pass it to other people or other processes, because I can use the WCF Test Client and make sure that everything is working properly. Now this other method, the get data using data contract, let's click on it. We see that it's got a Boolean value and a string value because it was trying to handle either. Again, it's a little bit more involved than ours. So I could send a true and invoke, and it sends back true. So we can try testing those things to see what those sample templates do that they sent for us too. Cool. Now the async methods are not implemented. It says that the async is not supported in the WCF Test Client because, why? because it uses type system threading. So since it's a multi-threaded type thing, you have to have a little bit more involved to test it. Okay, so I can close that. That looks good. Now I can create a new project to consume this service, right? Now we didn't do much with this service. We used the template, but let's just consume it. So I want to create a whole new project. I'm going to start Visual Studio again. So I'll right click and start it again. And I want, can't see that, can you? I want to create another new project, but this time I'm going to create a Windows Forms project. And I'm going to make this be Chapter 23 WCF Client. Now in my WCF Client, Intel, I'm just going to make this be a Forms app. It's not going to have any special stuff. And I'm going to make this much smaller. So on our form, I'm going to change my title. You know, I hate that. We'll make this be WCF Test Client. And then I want a label. It'll just be something like enter your message. And a text box. And let's just call this TXTBX message. And then let's put another label. And I'll just have that say response. And we'll use a text box to hold that response. And we'll make this one TXTBX response.
I was trying to double click on the labels to get put into them, and it always not okay the first time
I can get that nice code block. More code, more code. Okay, I'm going to put my button in the middle. Being super creative here today. And I'll just make it BTN send, because it's going to send our message. And I'll make it say, so our button is where we're going to do work. What I'm thinking is we'll just type our string in our message text box, click our button, and in our button code, we'll establish our connection with our service, send that string, and get our response back. Let's try it. Sounds easy. Visual Studio is mad at me. Okay, there we go. It's coming back. Okay, so now I got to remember what we got to do to get this to happen. First of all, we are going to have to set up a reference to our service. So that means our service needs to be running. So I'm going to go back to my WCF Service Project. Make sure I'm on my service1.svc file and start up that service. Now, another thing that we didn't look at last time, if you click on this line that says http:// localhost stuff, well, never mind. I thought it would show us over in the side, but you can see that that is your service's address right now. So we're running on the local host. It was given this really high port number 55649, and we're using service1.svc. So if we need that address, it's right there. So I can right click on that and copy that address because I'm going to need that for my client. Now I'm going to leave this running and go back to my client. I'm going to move this out of the way. And under our references, you know, before we've added a reference, we want to add a special type of reference this time. So we want to right click and add a service reference. And there's our address. Now I could paste that address in, or since I'm running on the same machine, I could actually use this Discover button and see if Visual Studio can find it for us. It can't. Now it says services in solution. So if I had made this project in the same solution, it would be able to. Since I made it a completely separate solution, it can't. So I'll paste in my address. Now I can click go, and it found it. Now if I expand my service one again, I should see those methods that we said were operational contracts that were available. So now our client has a reference established to that service. It knows how to find it, and it knows what operations are available from it. So let's click OK to add that. Yeah?
You lost me at the reference manager.
Paste your address up here.
I don't have that window yet, is what I'm trying to tell you.
Oh, right click on references.
Yes.
Add service reference.
Okay.
Is that it?
I was trying to add a regular reference.
Yeah, it's just a little different, so it doesn't give you that same information. So super easy, just got to find the right window out of the 700. Okay, let's add it. Click OK. And now, under your references, you should see that thing. Where is it? I've got service model. Oh, there it is. I was looking too low. So it's not showing up under our references. It's showing up here under our connected services now. Fancy. So if we needed to update that, we could. We would just come over here and update that service reference. And then we could change what we needed to about it. But just like some other Visual Studio things, it can be harder to change sometimes once it's already in place. Sometimes it's easier to just delete it and add it again if something's wrong. So, but now that I've got it set up as a service, I should be able to access it in my code. So I'm going to start. I have this service reference 1, and I want to be the client. Now, as we use this service, as we consume it, we're going to say, let's see, what thing do we want? I think we want our service client. I don't have any sample code in front of me. Hang on. We'll have to fiddle with it a little bit to see which one it is. And I think we want Service One Client.
You put dot service client on the first side.
It's happy then.
Yeah, without the parentheses. And it's a
I hate that.
It wants to know
Can
what
we
kind of
leave
object
this
we're-
off? Oh. Well, we'll just leave it real long like that for now then. We should be able to abbreviate that a little bit, but
well, because isn't it like
it's fine in it.
is it not a namespace within a class or the same kind of namespace at this class? So you know you need the whole thing.
Yeah, and if we put our using, let's
Oh, yeah.
try it.
You said using service references.
Yeah, let's see if we can get rid of some of that overhead service reference one. It's gonna let us.
It didn't like that at all.
Doesn't like that at all. Well, we'll just leave it long. Every time I get into it, it'll be a few minutes before it starts coming back to me. Oh, yeah. Okay, so now we have our client. So we should be able to use our client. So if we go to access our client and just looking at IntelliSense, it is associated with our get data method that we created in our service. So we should be able to set our result text box result dot text equal to our client dot get data, and we want to send it our text box message. Whoops. It's all upset. It says it's an integer. I'll do it. We'll just do it quick. Make it a really small integer.
You need a response.
Ah, see me getting all fancy this morning with response, and I couldn't remember it. That's the right term, though. Is that all we need? My cluttering around, my clunky typing here to try to get our right information so that we've connected all of these things together. So we're saying, looking at our service that we created, using the client, create a new instance, and I want to call that client. Now that I've got that instance created, use the get data method in that instance, taking my message and giving me back the response. So let's see if we can run it. And be sure to put just an integer in there or you'll break your app. That works. Is it working?
No.
Nope.
I didn't like it. Oh, I know what happened.
Do you see
I
it?
didn't put an integer in.
You could like really mess with people, just like add numbers on
Yeah, you can do all sorts of
Like-
stuff.
like, I didn't do that.
What in the world is that? So let's add a string capability because this is great, but all these numbers, yeah, unless like Colin said, we made it fun, it's not going to be too entertaining. So we need to know how to add a new item to our reference. So let's minimize our client for a minute and go back to our service. Now in our service, we need to stop running it so we can update it. And the first thing I want to do is copy my get data method. So I'm going to copy it. Or I'll just create a new one. I don't need to copy it. Public. This one is going to be we'll call it get string. What do you want our message to say? Huh? You entered. Oh, that's exciting.
You entered.
How about your string was?
Or
Is. It still is? Okay, be picky. And then we want words.
So do we, I guess technically, since it's we want to change the get data, like not necessarily have to, but like for functionality wise, if we're actually doing this, change it to return integers to putting it in here.
We could, you want to make it do a math thing? Let's make it do a math thing. So we'll say instead of returning a string, we want to return our value times 1,000 or something.
Times 5. Maybe.
Whatever your calculation is, you can do that. Make it be your calculation. Just don't put words in it. Now let's scroll down a little bit more. Nothing else in there we need to do. But I'm getting this weird error on our interface. It says service one does not implement interface member iService1.getDataInt. Ooh, it does not have the matching return type. So let's go to our service interface. And in our interface, we need to check those operation contracts. Because right here, we said get data was going to return a string. We need to change that to return an int. Now, do we need to add one of those for our new method? Yeah.
Do we in fact have to do that, or can we just make a separate method?
You
And
could
have
just
our
make
get
a
data
separate
format?
method. Mm-hmm.
Given what interfaces are supposed to do, I feel like that's a little bit more in the right spirit of things.
Sure, you could do that too. And then we want to create a new one for our string. So we need the badge operation contract and our interface information. Our string method returns a string. We called it get string. And its parameter is a string. And we called that parameter words. So we got our operation contract now set up to match. Mm-hmm. We shouldn't need any getters and setters. We could if we wanted. So now if we save all, remember we have to go back to our .svc file to run. We should see that new get string available. And now we should test everything because we did make some changes. So I'm going to try get data first. I'll put in a value.
Cool.
Uh-oh. I'm going to tell it to quit showing me that warning. Ah, I sent 5. My return value was 5,000, so it's working. My get string, I'll set my value to hello and run it. And it says your string is hello. So it's working. Here's the XML in the background too that it's sending.
I do not appear to have found these.
Did you update your operation contracts?
No, I didn't touch that.
You got to update those to get them to go the whole way through. Now you could have all sorts of methods in your code behind CS file for your service, but they wouldn't be available to distributed clients without the operation contract badges.
Can you go back to the get data
The way?
that you return the value of
Uh-huh.
you convert it to the string?
That?
Yeah, it says like they can convert integer to string.
Okay, so check in your get data, make sure you're only returning an integer, that you got rid of that string that was with it.
I thought that one was same as do you adjust something on the iService? On the get oh, okay.
Do you see it?
Make it integer, right?
Yeah, make it integer. Okay, so update your client then. Let's update your client to be handling both of these methods. Now, on my service, I have my service running, so I'm ready to work with my client. I think what I'll do is change my button. So I'll make my send button be send a number. So I'll make my BTN send number. And I'm going to double click on this to check my code before I do anything else.
I thought it was being created using
It's me. Now, since I changed my method name on my event, I got to go back to my button. Look, it's mad at me. Go to code. And I got to fix my code to say BTN send number.
I love how it can update everything else.
But not buttons.
Like in the button, if you look at the code around them, everything else has.
Yeah, why can't it update those? I don't know.
Yeah, everything else, but on click.
It's like, nope, that part I'm just going to break.
I would understand, like, if the code all changes, like, that would be fine. But if it's capable of changing everything
I know,
else,
it's just so weird because it's like,
and it just, like,
not
you
that.
control F and be like,
not
oh,
that.
with
Okay, I'm going to copy my button that cannot be dynamically updated for some unknown reason. And I'm going to make this one be send words. And I'll make my button name BTN send words. So I need to create a send words event procedure. Yeah, for some, it's these delegates. For some reason, these delegates, it won't fix. This thing should be exactly the same though. We should be able to invoke our service client. And as you guys work with your group project, there are many benefits to keeping the two projects in one solution. There are also many benefits to making it separate, but it will change things a little bit. Mostly like this. Oh, it doesn't?
Is it because we added it?
Oh, do we need to update our reference?
Yeah.
So come to Solution Explorer, and on your reference, let's try updating.
Oh, yeah.
Did that do it?
Yeah. Right.
Oh, great.
Oh, no.
Well, hey, we fixed the string problem. That's all that matters.
Yeah, that's right. Broke the other one.
Get that as an old problem.
Yeah, we shouldn't have to test those old ones. Okay, in our get string, we're going to pass in our text box message text. So that should take care of our word side. Words are always so much easier. But now, why?
We need to do .toString because get data is returning an int.
Ah, so now it's mad at us. Got that code long enough. Okay, let's try it. Let's run it. Hello there. Send words. Ah, it worked. Now my number 5,000.
Really confused somebody that's on a program and types in a number, gets sent words, and it still works.
Let's do it. The other one won't.
Yeah, you can't reverse that.
We can make it work. Convert it to an ASCII value. Serialize it. Send it through. You guys could make it work. Might not be able to read what it comes back with. It would be all encrypted and encoded.
You can always just set up a database to like have all like numbers in it, and it would recognize the keyword of every space.
Yeah, that'd be neat.
And then you could
send it
back. Because you can send back the actual numbers of string. So you could just be like, oh, the string is 7, add 7 to it. There's a string, you don't have to worry about adding mathematically. Just add like 75, just 75.
That'd be cool.
You can count the spaces.
I wonder if you could create like a Dungeons and Dragons dice roller service or something and let people connect to it all.
You
See
don't
what
need
they
to
do.
do this much for that.
Hmm?
Not really.
No.
You could buy, but it's like,
Yeah.
There's plenty of them available for free if you go like the place for
Online. All right. So that's what you guys are going to do. Let's check your project. I'm going to close this. Trouble? Not working?
yeah. You're converting the passage.
Yeah.
Because it needs to be passed. Or it's supposed to be running still. Leave it out for edit. Yeah. I didn't do that. Spamming is not the solution, Joe. It doesn't work the first time. You don't just go. You already running the other function.
No, I'm not.
There's nothing to see.
I didn't. I closed it. I just wanted to store it. All right.
you're still currently running it.
Not working?
It should work now. I use now.
No, you did not.
Oh, nice.
I have the same thing as you.
Taylor's back here using general expressions to see if his number is valid. Good job. Okay.
That's what's there. You can't click on it if it's not there.
Oh, that's why we updated it. Oh, it's not what it's with. It's with the app. If it's there, visibility is not.
It's see-through.
Now we can
Change the color.
That is so fast, you guys. Projects like that used to just take months and months. You can just get things done so fast. Let's look at your shipping project. That's your assignment, and you don't have any others if you look at it for right now. Okay, so it's kind of scattered out, kind of designed to be that way. Want you to kind of work with your group to solidify things, decide how you want to do things. So you're going to be creating kind of a mailboxes sort of company. You're going to allow people to bring their packages in for shipping. Now, when they say they want to ship something, you're going to give them some choices. They can use UPS, FedEx, or USPS. They can choose 2-day or overnight. And your form, so as you start out, you're going to have a form interface to greet the customer, right? And that's going to be some sort of customer information, their name and address, where they want to ship their first package maybe, or maybe you want it on another form for each package. You're going to decide that as you work with your group. When your form is displaying, you're going to, as they're doing packages, you're going to ask them what method they want to choose for shipping, how heavy their package is. You're going to call a web service then to calculate the cost. So your web service is going to do a little bit of logic. It's going to take that weight, and if it's post office, it's going to assign some value. If it's USPS, and that's the same as post office, if it's UPS, it's going to assign some value. If it's FedEx, some value. And then you're going to add like a premium if they want it overnight. You're going to come up with some way to calculate that in your web service so that when you're testing your application, you can tell the difference. There's different pricing for different shippers. If you pick FedEx, it costs different than if you pick UPS. So that's your testing. So when a customer is done then, they've given you information for all of their boxes, we should have an invoice generated. The invoice should show each item, each package, a subtotal, tax, so there should be some sort of tax calculation, and a final total. Oh, you should be able to print this invoice to the printer. Bummer, that sounds like an assignment for one person, right? Just being able to print. We haven't done that at all, and it's definitely not an easy project like it should be. It's a little bit more involved. Unless you find the right classes, and then it's super easy. They can be a real mess. Print shipping labels for each package. Yeah. And then invoices should be saved so they're viewable on demand. That just means that they should all be in a list for this day, right? So kind of picture it is the person that runs the mailbox store comes in the morning, they bring up this screen all day long, they ship things for people. All day long, the list is getting longer on the screen of invoices that they've generated. They could click on one of those invoices from earlier in the day and see what was all on that invoice. That does not mean that those current invoices have to be in a database. That's up to you. What you do have to put it in a database is a serialized chunk of that whole day's invoices. So we can take that whole list, serialize it, and save it in the database. Or you could do it in a more involved system. You guys have a couple of weeks to due date. It's like in December, so this is not due until after Thanksgiving. So I want you to really think about how you want to handle some of these things. Before we do, let's look at a sample invoice. You can make your invoice format however you like, but realize an invoice is a standard item. So here's one. And you get them, you know, if you order anything off Amazon, right, you get your invoice, but it comes in an email. So it's not as apparent to you how it's formatted. But you're going to have your company name up here, you know, maybe a nice logo. I don't know, it depends on how together your company is. You're going to have the customer information here, some invoice information, and then each of the packages that they shipped in a list with the subtotal, tax, and a total. If you look at the other invoice samples that are out here, you'll see they go from very plain to very involved, and that's just true. So as long as it has a list of all of the packages that the customer shipped, you're okay. It's not going to be graded on being this super fantastic invoice layout, just so that it has all of the different invoices listed. So you might want to start, today we're going to end here so that you can get together, and let's see who's missing. We have some people that are not here to help their Oh, is it? Well, good. Then you can just decide how you want to do it. Don't have to worry about their silly ideas. Actually, your group is all here. Silly.
Oh, is this a different group?
Yeah, this is a different group. So go to project groups because this is a different group. I split you up from your study group because I wanted you to get to know some other people. Now, you guys are all really strong. You're all really strong developers in this class. So it's hard to kind of split you up. But I did try to put a super strong person in each group that I felt like could probably, you know, pull everybody along if necessary. But then there's other really strong people. Like I said, you guys have done a really good job all semester. I wish I could pair some of you with the afternoon class people sometimes. It's interesting how classes pull each other along. All right, so that's your group. It is a little different than you've been working with. Austin's not here for Taylor and Noah. He's missing. And Tyler's not here for Hunter and Clint. But I think other than that, at least you have people, oh, and you and Seth, you're here. Colton's not. Colton, if you email him, it's usually pretty good about responding. Austin may not respond as well to emails, but he definitely will complete his tasks. So I don't think that we have anybody in here that won't complete the tasks they're assigned. I think that you guys are really lucky to have such a good group. You've all worked so hard, and you really don't have anybody that won't work well. So what should you do? Sit down and make a list. What all's going to have to be done? We're going to have to do this task, this task, this task, this task. Organize them. How do they fit together well? All of these tasks have to do with this thing, and all of these tasks have to do with that thing. They would be good to be organized together. Then assign them out to people. So don't assign things like, you do the service, I'm going to do this. No, make a list and decide who has to do what. The service is going to take like 10 minutes to make. Don't give that to somebody as their whole contribution to the project, okay? It's not worthy. Make a list. So that's what you should do today. Make a list, get an idea of how you're going to split all this stuff up. We don't have any other presentations to explain any aspects of this. So, yes. Oh yeah, Taylor's presentation. Let's do that before we get off. Thank you, sir. I'm ready. I was done with those. I was like, yeah, we did them. Okay, let me release this so he can show us his awesome presentation. All right. We had such good ones too.
share my screen.
Mm-hmm. Oh, neat.
So my presentation is over diving into the code of the C# program I made before I entered college, and kind of comparing what I did to what I would do, and some of the things I didn't know back then. So some of the first things I noticed with the code, and I'll show the code in a moment. But some of the things that I noticed was I did not use comments, and it made it very, very difficult to actually understand what sections of code I actually did. I've learned my lesson. And I also noticed that I used mono behavior from Unity a lot, and I didn't necessarily know what mono behavior was or what it added to the class. And I also did not have very good naming conventions. I have bad naming conventions. So this is kind of the Unity specific things that I used, but I didn't necessarily expand more on this. And these are, mono behavior is the derived class, and the rest are just methods from mono behavior. And I didn't necessarily understand that I was using those. So I have lots of scripts to handle all the different aspects. And these are all the scripts that handle the player in the game. And my art assets I got from a public domain library, so I was able to play around with that and everything. And I've also got asteroids, so you have a player that shoots asteroids, and the enemy, which is a bunch of guys that follow the player to shoot out, and some other miscellaneous stuff. Just something that kills off the enemies once they are no longer in play. Score handler, all that. I didn't necessarily know the power of classes, so that I can make a class and kind of make my layout and pull from that. I just kind of threw whatever I threw out there. And most of my programming experience before C# involved just making a function and then just having it go through a list of actions, and then it's done, and not necessarily using returns and all that. And some things I would change if I were to make this today. I would definitely make use of derived classes with abstract and virtual methods, because I found that those would be very, very useful for what I was doing. And I found that throughout my code, I was repeating myself a lot. It was just a mess. And comments. Yeah. So I'm going to pull up the code.
He does have a point about class-oriented programming and how it effectively enables us to, instead of treating code as just a list of instructions, it's more like putting together a Lego castle. You get to make different building blocks that you then put together in ways that make sense.
So if we get all of this actually runs on my computer because I have Unity installed. I don't think Unity is installed on this machine, so there are errors.
Yeah, it's installed. Just go ahead and bring it up.
But, some of the more interesting ones, we'll go to enemy handler and see what that entails. So the the start method, what that does in Unity is when on the very first frame of the game running, or once it is loaded, it will immediately execute that script. And update makes it so that that script runs at every frame. Those were some things I actually learned while researching this, and I just kind of threw them out there. I didn't necessarily know what all I was doing at the time. One of the methods, I still don't necessarily know how it works. I kind of went on message boards and fumbled around. Was this get closest players, or find the closest player? And that was, and in essence, I believe it does, is it sends out vectors in Unity to look for players. And once it finds the first vector that is closest, it returns its position. And, these are the only 2 comments throughout my entire project.
It was on in the book.
So we're going to the player handler. The enemy and the player are the ones that have the most code in them. But I do use things like, here's an example of the derived class mono behavior. And I just kind of threw it out there because that's what everything did. You know, and nothing worked with it was missing, so I just went along with it. And I was making objects with classes, but not necessarily knowing that that's what I was doing. It's just, hey, this is kind of what you do. And really, I learned C# from watching the YouTube video for maybe 10 hours total. And so I didn't necessarily know everything. But my naming convention here is not right. I'm noticing for public variables, I should be using camel case and capitalize the first letter. And for privates, private is correct, but public isn't. And also my custom-made methods, the ones that I made to make the game work, they aren't applied to naming conventions either. What else? So I guess that's really it. I do have the game with me.
Let's see it.
Just game share. So you're able to shoot asteroids, get score points from them. Based on the score, it increases the difficulty. I think at what is it, 130, the first enemy shows up. And when you kill an asteroid, or when you kill anything, it has a chance of dropping power-ups. So this one would increase my shield's health. So that's really it.
What are those 3s down there by your ships?
Oh, look at the number of lives. They did not make that apparent.
Oh, okay. Well, I just wondered. They were all the same. I like it.
For this to be 4-player, but
Oh, see, I didn't know if you were going to go across and use different ships. I see it's a multiplayer.
yeah, I don't think I enabled control for all of it. This was
Cool.
a project I made in 2016. Kind of the summer project in 2016, and it really introduced me more into programming than what I had done before.
It's nice. Like it. Give him a hand. Thank you for reminding me, Stuart. I was going to totally forget. I was done. I love it. Yeah, I'm going to end our meeting here.